All right, I'm Rosemary Wong. I'm a developer advocate for HashiCorp. Today I'm going to talk about service mesh across hybrid infrastructure. So just to level set a bit, what you'll see today is less about Terraform. You'll see mostly Consul, but the idea is that I'm going to focus on some patterns for service mesh and why it might work across hybrid infrastructure. Because a lot of the times when we talk about service mesh, it tends to be in the Kubernetes space or the container space. So why do we care? And why is it so interesting in hybrid infrastructure? At least for me. Hope you find it interesting too. So we'll talk a little bit about the challenges in hybrid infrastructure. And we'll focus on how we use a service mesh and service discovery to build insight between AWS and data center. It's particularly challenging. We'll go to the demo, which again, hope it works. And we'll talk about some takeaways from that. All right, so how many in here are in sort of a hybrid infrastructure formulation, or you're running mostly in data center? Oh, OK, yes, great. All right, so you all have heard these challenges before, I suppose. When I was working in hybrid infrastructure, meaning that they were moving things to AWS, the lovely question of connectivity was a really weird problem to solve, right? So in my data center, I had some servers, I had some databases, and that was pretty much all I could really describe, right? And the servers had maybe Kafka on them. The databases were maybe some kind of SQL database. And our addressing was really specific. It was really specific because that was the way we had to configure it, right? And then when we moved to AWS, we had this beautiful wild west of amazing products that we could use. And it was amazing because we could use Kinesis streams, we could use S3 buckets, we could use Lambda, we could use EC2 instances, we could use the whole gamut of things. But the networking and the IP addressing and general infrastructure in AWS isn't quite the same as your on-prem or corporate data center, right? And so setting up connectivity was a non-trivial task because you kind of had to figure out what went to where, how it was routed. If you had a firewall rule set somewhere that you forgot that existed somehow, and then someone else added more firewall rules to it. So it was kind of complicated. And inevitably, I always ask this question. I probably ask this question once every 2 weeks, which was, why won't X connect to Y? It should just work. And it was pretty complicated because I would be looking at a security group, and then I'd be looking at a network, and I didn't know if the security group was supposed to go to the network or the security group was an identity. It was extremely confusing. And maybe it was because we didn't set it up correctly, but on the other hand, that context was sort of lost in interesting ways. And I think what it boiled down to was that a data center is a system of record. We rely on a configuration management database or certain records to go through and ascertain what belongs to what, for the most part, right? So a line of business has servers at 10.0.0.2, 10.0.0.3, and for some reason 10.0.0.10 for some peculiar reason. All right, so we really didn't know what was to what, and we had to sit there and figure out what IP addresses went to what hosts and who actually owned them. And in some regards, we also had a very high trust environment in the data center, right? So everything in the VLAN could pretty much talk to each other. Maybe you could firewall things in and out of the VLAN, but you couldn't really do much within the VLAN to actually sort of get finer grained control between machines, right? And for the most part, machines were dedicated. They were fairly homogeneous in nature. They were pretty much one of generally six servers, although I make some exceptions to that, right? And so for the most part, they were pretty well known in how we configure that. But AWS was a system of engagement, right? We engage with it. We don't necessarily have records, right? So when you ask someone to give you AWS inventory, you get this massive list that tends to result in an AWS bill, right? It's not really a database complete with all of your information about AWS. So AWS is service-based. It's dynamic. How many people here have static lambdas, like lambdas that are pinned to a specific IP address? Not really. That doesn't, well, sometimes. You can have it, but you might not, right? For the most part, there's the expectation that it's ephemeral, that it's dynamic. And containers are also a big part of this, too. As a result, it's low trust by definition, right? Because you don't know who's talking to who. You can't really say it's an IP address that changes. Your identifier is no longer this IP address or this host name anymore, right? So you, by definition, have to apply network policy by identity, by the service, by how you engage with it. And as part of that whole discussion, AWS is also very on-demand. That's why we use it. And for the most part, these workloads are heterogeneous in nature. So you see a lot of them, and they can be very different. So why does this matter, and why does it go back to why won't X connect to Y? Well, the problem is that, as I mentioned before, insights are really difficult without context, right? When you've got a system of record versus a system of engagement, you've got two different ways of talking about something. And that means that you have to translate between the two. And so this is a lovely TCP dump. I don't actually know what it means, because I don't have context to it. I don't actually know if it was going from data center to AWS, and I don't know if it went from AWS to data center. Honestly, I lost all context because I just got the snippet, and somehow or another, I know these requests were coming in and out. So if anybody can debug this, right, with any information about how AWS connects to your data center to AWS, well, they're expert level, right? So I'm not, sorry. All right, so how do you solve this? How do you start thinking about making a common translation between how you talk about your data center and therefore the insights that have context to this lovely thing that we've been using in AWS? Well, since AWS is a system of engagement, or it applies a system of engagement approach, why don't we apply a system of engagement in your data center? That seems kind of tricky, but what if there was a way that we had an intention that we said, hey, there are services in my data center, and this is how we engage with them. For example, it's an API, it's PostgreSQL, it's a UUID. So all of these things, let's say we were actually describing as services and not as IP addresses or hosts. That's puzzling. That's an interesting thought. So let's kind of continue along this line, right? If we've got a system of engagement approach in our data center, and we want to make sure we bridge the gap between AWS and data center, well, what's the required functionality that we need? Well, we need to discover AWS resources and services. We need to discover data center resources and services. And we need to manage requests between AWS and data center. Sounds simple enough, right? Well, actually, it could be, weirdly enough. All right, so how do you start to build insight between AWS and the data center, right? How do you start to build insight in your hybrid infrastructure? That's the big question. So I'm going to show you a bunch of tools. Take it with a grain of salt. You can substitute your tools. Okay? All right. So AWS Cloud Map is service discovery for cloud resources. When you use Cloud Map, what you're basically saying is that there are a list of services, they're associated with a DNS, and that gets created in Route 53. So in some ways, it's very dynamic, it's very neat, because what you get to do is say, as cloud services come up, I register them, and they appear in Cloud Map. They have a lovely DNS associated with them. So that's service discovery within AWS, right? But what about the data center? We do a lot of weird things at our data center. We can't really use AWS Cloud Map for it, right? So this is the lovely bridge. HashiCorp Consul can help you do it, right? So if you put HashiCorp Consul as service discovery and service mesh in your data center, what you can do is start to bridge the gap and build some insight. So HashiCorp Consul, for those who are not as familiar with it, is actually a whole multitude of things, but it also includes a service mesh. So it provides a service discovery, which is that catalog, very similar to Cloud Map. And it provides the ability for you to do some fine-grained traffic shaping, right, that you can take advantage of on a service mesh side. So I'll explain a little bit about service mesh later. But the idea is that in your data center, you might be using Consul, and in AWS, you might be using Cloud Map. And there's a nifty way that you can actually synchronize between both, which is actually pretty cool. So if you do service discovery in AWS, you can synchronize to service discovery in your data center with Consul, and the two of them actually can register with each other. So it's bidirectional. You can set it up unidirectional, or you can set it up bidirectional. So you can synchronize from AWS to Consul, or AWS Cloud Map, or Consul to AWS Cloud Map. Oof, caught that reversal. And if you want to, you can even say that you're going to go with a managed service mesh, right, such as AWS App Mesh, where it routes and observes for all the services within AWS as well. So this is maybe how we can get to it. But what does it mean? Like, why is this practical, and how do we think about it, right? So let's actually go through a use case. Let's actually go through a migration of an application. So we're actually going to migrate an application to cloud, AWS. All right, so the first couple things we're going to do is I'm going to walk through the configuration of AWS Cloud Map and HashiCorp Consul in this use case, right? So this particular situation, it may not be applicable to your specific, but we're going to do something that's at least representative of it. We're going to register services and resources in AWS and in the data center. So for the most part, it will actually have a service catalog detailing AWS and the data center. And then we're going to manage requests between the resources. And we're going to take a look and see if we can actually determine whether or not X can connect to Y or Y it can't. All right? So I'm going to push the big red button. All right, ready for keyboard? OK. All right, so what's a service mesh? You saw this in the title. A service mesh is an infrastructure layer. That's the most simplistic way of describing it. But what it's doing is it's layering on top of infrastructure resources. And it's allowing you to control the traffic within this kind of mesh. So within the infrastructure resources that are a part of this mesh, you can control traffic. So what you'll see here is just a short representative diagram of Consul specifically, but most service meshes consist of a control plane. So if you're using AWS App Mesh, for example, that would be AWS App Mesh. In this case, it's Consul, and a data plane. The data plane itself has a bunch of proxies. All traffic goes through proxies, okay? So for the most part, the control plane has rules, and the rules get applied to proxies, right? So the rules within the control plane can say, hey, send 10% here or send 90% here. So that's how traffic shaping works within the service mesh. You can also use service mesh for circuit breaking and other kind of functionalities as well. But for the most part, we're just going to focus on two use cases, which is canary and A/B testing. But what's really interesting about a service mesh in particular is that it's layer 7 mostly. There are some layer 4 capabilities, so for those who are interested in networks. There are some layer 4 capabilities, but mostly it's on layer 7. So I'm not configuring firewall rules. I still have to configure them to a certain degree. But what I'm doing now is actually doing really fine-grained shaping. So why is this important in hybrid infrastructure? Well, I will actually start by showing our premise. Imagine I have an application in a data center. It consists of 3 pieces: web, API, and database. Web, we've determined we can't migrate that easily. It's a thick client. There's some other issues with it. We can't do really a good migration without some good user testing around it. So we're going to step back and let it sit for now before we migrate it. We can move the API pretty easily. At least we think we can. We refactor and migrate it to AWS. And then we've got a database. The database, because of the data in it, we don't know if we want to migrate it right now to AWS. We want to, but we're waiting for some compliance and security assessment in the process, right? And so what happens in this particular data center, right? Well, the first thing I'm going to do is, of course, migrate it to AWS, right? So I'll migrate API to AWS. And it seems pretty cool. You know, it's just sitting there. But I don't actually know if it works or not, to be totally honest. And I won't know if it works until I connect back to my on-prem database. So here's where the service mesh with Cloud Map can actually be really handy. What if there was a way that for every service that was registered in my data center in Consul, it also registered in Cloud Map? And that's where this nice synchronization is really useful. So what actually I've done is I've deployed the mesh and service discovery capability in my data center. What this actually looks like, and get ready for some Terraform, everyone. What this actually looks like is pretty much just a configuration of Consul here, which I'm not going to go too deeply into, but this is the actual server, so this is my control plane. And what I've done is basically deployed it as a Consul server, right? So it's just saying, here's a Consul server, I've deployed it, it's great, it's running. And all of these lovely endpoint addressing, the control is all in the Consul server. And the other thing that I've done is also on the same machine, now you can do this on a different machine, but on the same machine, I deployed a binary called Consul AWS. This is a binary that uses calls to AWS and Consul and synchronizes between the two. So you can say sync catalog, and you also need to Consul to AWS. So it can be bidirectional, or you can make it unidirectional, depending on what your desire want to be. And by the way, you also need access to AWS when you do this, right? So you'll need access to Service Discovery and Route 53 while you're at it, because it's using Cloud Map and Route 53 for registration. So when it makes that synchronization, right, what it's actually going to do is when I deployed the lovely mesh in my on-prem data center, what you'll see is that I registered API, database, and web. Oh, great. First part of the demo worked. All right. So API, database, and web are all there, which is great. And what this will actually do is it will actually synchronize within AWS Cloud Map. So as you can see here, I have a domain name, which is in Route 53. It's private DNS, in this case called example.terraform. And what you will see here is that by magic, AKA the Consul AWS binary, it has now imported it from Consul to AWS Cloud Map, which is great. Because what this means is that now I can resolve from API to database, right, using AWS Cloud Maps entry. So what does this actually look like? Well, let's actually take a deeper dive. So what I'm going to do is I'm going to actually call my lovely API because I don't actually know if it works, right? So I'm going to call it and hope that it connects to the database correctly. So what you can see here is that when I called the AWS API on AWS, it's actually connecting to the database on-prem using database.example.terraform. So it's using that cloud map Route 53 domain to actually connect back to your database on-prem, which is really neat, right? Now, if you don't have a handy-dandy debugging API like this, you might be able to you could use tracing, for example, so you'd see a very similar result here, right? Right now it's on web on-prem, but if I say API on-prem, well, it's not happening right now. All right, one part of the live demo didn't work, but that's fine. All right, so basically what we've done is we've done one thing, right? We've done a very simple thing, which is to go from API on AWS back to the data center. And I didn't need to configure Route 53 on my own. I just sort of had it magically happen. All because the catalog was pre-populated, the service discovery was already done in my data center. So that's where this is really neat. So not so much work for me. All right, so that's pretty good, right? But what about the next piece? Like, how do I actually go from migrating the rest of it? Like, for example, what if I want to actually put traffic toward the API from my web that's on-prem? Like, it's a thick client on-prem that needs to call the API on AWS. Like, I don't even know if API on AWS works, but I should be able to test if it does, right? So how would I do that? Well, in this case, I'm going to stretch the mesh. Okay, so, sorry, it's not the correct term, but I'm stretching the mesh. So what I've done is I've deployed a second Consul server in AWS. So it's a second control plane. So remember, 2 control planes, 2 meshes. And I have been given the illusion of stretching the mesh by data center federation. So Consul uses a concept called WAN to actually communicate between data centers. So AWS data center and on-prem data center are effectively under the illusion that they are one mesh, right? Which is kind of trippy, but that's okay. All right, so what it comes down to is that when I register API into its own mesh, it will see it under AWS data center, and then everything else would be seen in the corporate data center, right? So if I actually go here, I've actually already done it. And if I actually drop down, you see there's a lovely AWS data center, and you'll see API is actually in the AWS service catalog, right? So that's pretty neat. So what it's basically saying is right now, I've now stretched my mesh, which is pretty cool. Now, here's the tricky part. I need to be able to split traffic, right? So let's say I'm ready to actually do a canary. And this is a very dangerous thing, but we all need to do some kind of mitigation. And in true canary, you would do like 10, 20, 30, 40. You would actually have smaller increments than 50-50. But for the sake of this exercise, let's just say we're going to cut over 50% from web to API on-prem, and then go 50% to API on AWS. All right, so let's see if this works. So the first thing I need to do is to actually configure the service resolver. So as part of my mesh, what I have to tell the mesh to do is resolve the API, right? So I have to tell the mesh, hey, if you go to API on AWS, you need to go to API on AWS. Otherwise, it will just always go to on-prem because it's locally resolving to on-prem. So for the most part, the service resolver is going to go API on AWS. All right. And what I'm then going to do is also provide a second configuration that splits traffic, right? So if you're doing vanilla Envoy proxy, the idea is that you would actually declare like the splits to the clusters, right? So when you split, I'm basically saying 100% goes to API, which is on-prem, and then the rest of it, 0 goes to API on AWS. Okay, so let's see if this actually works. And I actually have a handy-dandy command to do that for me. So all I'm doing is actually pushing that config out to Consul. And it doesn't matter which console. In this case, I'm pushing it to Consul, the control plane, on-prem. So I'm pushing it to the on-prem control plane, but it will propagate to both, right? So the idea is that now here I have this configuration that says, OK, 100% goes to API on-prem, and 0 goes to API on AWS, which is pretty neat. So as long as I continue running and checking my lovely fake service, which is my web client, my web thick client, for example, you'll notice that it's always just going to go to API on-prem and database on-prem, and it's all going through the mesh for the most part. But let's say I want to do that 50%. So I'm ready to go 50-50. All right, so how many people think it's going to work? How many think, OK, thank you for your good faith. How many people think it's probably not going to work? OK, well, some people are less skeptical. All right, I appreciate it anyway. OK, so let's say I've deployed. It's 50% on-prem, 50% directed API on AWS. All right, so ready? All right, let's see what happens. Oh, that didn't look good. Web on-prem to API on AWS didn't work. OK. Oh, OK, that was good, right? Maybe it was just, it took some time to resolve, I think, right? No, that didn't work. Oh, OK, well, that works, but it's going to on-prem. OK, see, that's fine. No, what's going on here? OK, so I'm just going to go to my tracing because, all right, so notice there's some errors. It's intermittent. I'm confused. I don't know what's going on. How many people have probably gone through this process where they're like, wait, I think it works. It doesn't work. Yeah, so this is what happens when you refactor an app and you put it on AWS, and not because of AWS, it's because you refactored it wrong, right? So human error, and we're not sure what's going on, so we need to maybe like go back and debug. Now, I'm going to do a little cheat and say that I purposely failed it. So I'm going to fix it with a toggle, because now I'm just going to toggle everything back to that. And I'm actually going to commit it. Fix API on AWS. So what it's going to do is actually sit there and push it and build it. So I'm going to let that run for a second. But what's actually really important about this particular configuration is that with the mesh, what you're able to do is a couple of things. What you're able to say is like you can trace between AWS and on-prem, right? You just add the mesh on top of all this and passing the headers and stuff. So you can actually see where it's going. The other important thing that you can do is actually the proxies are really useful for ascertaining whether or not you're passing it to the right place. So the proxies themselves are always, weirdly enough, going to be on localhost 9092. And that's because, remember, the proxies sit sidecar. They sit right next to the app. So everything funnels through the proxy first, so that's why you see the localhost 9092. So that's when you know it's going through that proxy. So you can see here that it's gone through the web proxy, but for some reason, when it hits the API, the actual app itself, the API on AWS, sends back an error. So it's not saying that the database is sending an error. It's saying API, the app itself, is sending an error. So what's really neat about this the whole thing is to say, OK, now I gain some insight between the two. So now that I've started to do this migration process, I'm able to get some idea of what's going on and what information is being passed where. Now, what's important to do that I didn't quite do yet was that when you do this, you should go back to 100 and 0, right? That way, if you, let's say, have users who are actually using this and they're going to their web on-prem and you're making calls and they're doing things, they don't have downtime and they're not affected. So the idea is that with a couple commands, all I do is I just cut it back over 100% to on-prem and then 100% back and 0 into API on AWS. So what you'll see here is that it's actually building. I have to rebuild it, but that's fine. All right. So ideally, whenever you do a canary, right, you have this 50-50, and you'll evaluate whether or not it works, right? You'll actually say, OK, API is ready to go. And eventually you'll get to a state that you'll cut over completely, where you go from 0 to 100%. And 100% of traffic is going to API on AWS, which is great. Meanwhile, API is still resolving to the database with the database.example.hero. So it's doing it through Route 53, and it's doing it through Cloud Map. Now, why would you set it up this way? It's because maybe database is really static. You don't expect it to change that much. For the most part, you're not trying to cut over traffic on the database layer. What you're really trying to do is assess whether or not the pieces that you're refactoring are actually ready for production. So let's say we've run API on AWS for a while. We know it works. We know it works with web on-prem. So what we're going to actually do is we want to permanently make it that way, right? So we want to say, okay, let's stop with the whole 100% thing. I ideally want to get rid of my service mesh later on in this journey. So I'm just going to funnel API on AWS to API on AWS, right? I need to resolve from data center to AWS. So remember, we went from AWS to data center pretty easily, right? We just said, okay, synchronize, and it's great. We saw the two. But can we go from data center to AWS? Well, the answer is yes. If you're using service discovery in your corporate data center, the idea is that service discovery often comes with a DNS of itself, right? And so in the case of Consul, what you'll actually see is a lovely DNS here that if it's, sorry, wrong file. What you'll see here is that if I actually resolve to API on aws.service.consul, what it's saying is that you're resolving to that DNS. So if you use service discovery, service discovery tool in your data center, what you're going to be able to do is say, okay, I'm going to get DNS specifically in my data center. And what this will allow me to do is actually, because remember we did this bidirectional setup, so anything in Cloud Map should be able to go back to my data center, right? All right, let's see if that's the case. Well, this failed to open the page, but that's because this is still running. By the way, if anybody's curious, this is Terraform Cloud, and it's running it for me. But basically, what I'm first going to do is actually register my API into Cloud Map. So if I were to do this, all it's going to do is just make a call to Cloud Map and say, hey, this is my instance. This is going to be in Cloud Map. That's the DNS. OK. So it'll take a little bit of time. You can auto-register it if you would like using AppMesh. If you have AWS AppMesh, this makes it a lot easier. But I'm just going to manually register this for now. And as you can tell, if I refresh this and I go to API on AWS, right, which is actually in my Cloud Map namespace, you'll see that it's resolving to this instance, my new instance that I've created, right? So basically what I've done is said, OK, API on AWS, I've registered you in Cloud Map now. Now, did this go back to Consul, right? Because basically, did this go back to my data center so that I can actually use it? Well, let's go back to the data center, and let's see. So if you can see here, what it's actually doing is it's actually registered into Consul. So it's saying, hey, I'm going to resolve to this address, right, on 9090. That's where my service is. This is where my API on AWS is, right? And that means that Consul will allow me to use it as if it was just like a Consul service, which is pretty interesting. So I can actually tell it's from AWS just by this tag, and it actually tells me it's from AWS. So is this true, right? Is this actually real, or am I just saying that, hey, this is actually going to happen? Well, let's see if it works. So I'm going to open back up all of my services again. Remember, what we're trying to aim for is web going to API on AWS, and then back to database. So what you see here is web. It's no longer using a proxy. It's going to use API on aws.service.consul. And then, of course, our API goes back to our on-prem database. Now, this seems really weird. It's bouncing back and forth, right? But when you're migrating, when you're trying to do like a strangler pattern for as you're migrating in hybrid infrastructure, it's pretty common to have this problem, right, where you have one service sitting in AWS and the other one sitting in on-prem. So here we have API on AWS. That's pretty neat. And under the hood, I won't go deeply into how you configure that. So if you have questions about it, feel free to come up after and ask me. It's a deep dive on kind of the DNS aspect. But we're talking more about the service mesh patterns. All right. So now that we've gotten this done, that's, it's pretty useful. But what about our web client, the one that we said we couldn't really move, right? So we said it's a thick client, we're not really sure about it, it requires quite a bit of refactor in order for me to get it right. Well, let's say we actually attempted it, right? We said we're going to try to refactor web, and we're going to try to get this on AWS. So we refactored it, it's great, things seem fine. Generally, from a functional standpoint, we're able to independently call this web and say, hey, it works, it calls the API, everything is great. And let's say we're just like, but we're not sure, we're just not sure. We don't know for sure if it's good or bad, if users will like it more, or they'll just reject it entirely. So this is where an A/B test would come in, right? And in this case, I'm continuing to stretch the mesh. I'm not using another kind of concept right now because I still have things in the data center. So workloads that are predominantly in the data center, I'm just going to keep on my mesh and continue stretching it. So what you will see here now is that I've actually gone and continued to maintain the stretched mesh where AWS is registering both web and API. So you have both. So that's pretty common, okay? So you've got web, you've got API, and now what I'm going to try to do is see if I can A/B test. So in an A/B test, what we're going to say is a group A gets directed this traffic, and group B gets this traffic. In theory, this should be fine. And what you'll do in the case of a service mesh, or if you have a proxy in place, is you're once again going to configure a resolver. The resolver will therefore tell it, like, web on AWS should go to web on AWS, right? And then if I go, there's another not new concept, but another concept that you would apply, which routes, right? So you would route the traffic between A group and B group. In this case, we'll say our A group is the default, so it'll always go to web on-prem. So any user that's going to go use this client is going to go on-prem, right? Because we want to make sure that they're still getting the same experience. We're not going to try to affect them. But let's say a subset of users want to go to web on AWS, right? We want to see how good our new interface is. We want to make sure that any refactor that we've done is actually effective. The functionality is what we expect. It's also more overall, more positive experience for our users. So in which case you can add a header, and the header would just say data center AWS. Now, it wouldn't actually be data center AWS. You might do something else. But the idea is, let's say if I had a header and it's data center AWS, it will go to web on AWS, right? And so similarly, I will also apply this. So I'll apply the traffic, and what it will do is actually configure it so that it's actually routing between the two. So under the hood, what this is really doing is it's configuring the proxies. So this is pushing this to Consul, the control plane, and Consul, the control plane, is telling the data plane, all those proxies under the hood that sit right next to the application, hey, these are the things that you want to do with it. So now that I've gotten the headers in place, what I'm going to do is I'm going to test it, right? Because why not? So I'm going to test it by saying, hey, let's check if I'm an A group, what happens. If I'm an A group, it should just default to my web on-prem. And so in this case, I should just see on-prem, right? It should just go to web on-prem, which, by the way, is still going to API on AWS and still going to the database on-prem. So it's still doing the triangle right there, right? But then let's say I want to actually test my new web on AWS, right? I want to make sure it's good, there's functionality to it. Well, now if I have that lovely header, data center AWS on, you'll see that it goes from web to API, AWS to database on-prem, right? So overall, like pretty interesting pattern, right? I can actually use the service mesh to help my migration, right? To basically mitigate some of the risks that I'm taking as I'm continuing to migrate applications to AWS. So in the final diagram at the end of the day, what you might find is that you don't really need as much of the mesh as you thought, at least the Consul service mesh, the data center's mesh as much as you thought, right? You might just keep it around just so that it's synchronized with Route 53. So your final state might be, I've got a database, I do some service discovery, it's in the Consul service catalog, and it just references and synchronizes back to Cloud Map. And then in the next state, what you might say is like, hey, I'll take away the service mesh because I don't really need it anymore, during this migration, but I do kind of want to keep it for, just continually assessing the traffic, shape the traffic between multiple workloads in AWS, and in that case, you would use AWS App Mesh, right? So you use the tool that works within the certain situation in this weird kind of gray area of migration. It's not always clear what's something that's useful and what's not. But what you can at least say is that with some of these tools, you can actually mitigate some of the risk as you migrate and as you continue to run in a hybrid infrastructure way. So with that, I'm going to switch back and do some takeaways. OK. All right, so what did we do at the end of the day? What we did was we said, all right, let's get some visibility into our hybrid infrastructure, right? As requests go from on-prem to AWS, let's get some additional visibility. The idea is that maybe we'll ease some operational complexity. As you saw here, I had a nifty application that told me where things were going. But not all applications are written that way, right? So if you want to do tracing and you want to make sure you track requests between data center and AWS, the idea is that you need to add some layer on top of that, and that's where the service mesh comes in. Now, AWS Cloud Map, AWS App Mesh, and HashiCorp Consul can all kind of manage and provide insight in this way. So even if you're just running on AWS or predominantly on AWS, consider using CloudNet, consider using App Mesh so it automatically registers and service discovers so you don't have to do all of this manually, as you can tell that I did, right? Now, the other piece of this that I think is most important is what we did was actually create a single system of engagement, right? So we didn't say that we're going to take our record and transform everything. What we're doing is we're layering on top a system of engagement that's a common language for the way we do services and manage traffic within AWS, and we could get it back into the data center. So what we're doing is we're layering a system of engagement. We're not looking to build a new system of engagement, right? We can continue maintaining the records that we need in the data center. We can continue using all of the tools that we want to use to manage our data center. But as we migrate, right, we're actually able to get insight and mitigate the risk that we might have as we continue to move. Okay? So resources, what can you do? What else is really useful for you as you continue to go on this journey of hybrid infrastructure? Well, systems of record and systems of engagement, I wish that was my term. That's not my term. I have a white paper here that actually probably explains it better than I did. You can take a look at Cloud Map. You can look at App Mesh. App Mesh is actually really useful for things that are across AWS workloads, so Lambdas, EC2s, EKS, ECSs, right? So if you wanted just a service mesh for things in AWS, maybe just do App Mesh. But if you've got a data center and you're going through this pattern of migration that spans years, you might want to consider looking at Consul or some other kind of mesh capability from another tool. So you can take a look. There's a guide here, and there's some more information specifically about Consul and Cloud Map directly. All right, thank you. I know this is a little shorter, so I'd like to open the floor for questions. And I was told to walk up to the mic, to walk up to those two microphones in the center if you had questions. Oh.
Since you guys showed a lot about AWS, have you had a use case with Google or Azure as well, doing something similar?
Yes. So all of the, and that's probably something that you would, think about if you're thinking about other different clouds, right? This situation would also apply. You just have to make sure that as you stretch the mesh, it is with the tool that you intend to stretch it with, and you kind of evaluate whether or not it does. But yes, it does work. We've done it with Google. We've done it with Azure as well. So it goes across the board. Mm-hmm.
When you connected the two data centers together, did you use a mesh gateway for that, or how did you get the networking to go between the two?
Good question. OK, so the magic under the hood, which I didn't go too deeply into, is that when you federate between data centers, it's WAN. And WAN can be done either over kind of like a management network, so you can have one network connecting the two, or you can do it over public. The mesh gateways actually facilitate kind of traffic between the two data centers, and MTLS encrypts them. So the ideas of the mesh gateways, which we're seeing, I'm going to actually swap back to this one so that you can see here a little better. Not this one. 6. OK. So that's actually not it either. We'll go back. All right. So what you'll see here is those two Consul mesh gateways sitting between the two. And so all the requests that happen between data center and AWS to data center go through those mesh gateways, and they're encrypted. They're deployed separately, so they're not quite data center federation per se. The data center federation, the WAN federation, is typically done on a separate network. Yep. Okay. Any other questions? Oh, could you grab the mic? Thank you.
In your demo here, all these apps, are they running on inside container, or are they running and just processed on a VM, or?
Yeah, they're processed on a VM. The idea is you could also run them in containers as well. You would have like a sidecar proxy container and the app container. But in this case, they're just on EC2 instances. They're just running as binaries by themselves. So if I actually show this template here, what you'll see is that there's actually some config up there. This is like a web service, and all it's doing is just running this binary. So it's running a fake service. They're on EC2 instances, but you can also run them in containers. The same applies if you're using Kubernetes, if you're using some of the other tooling as well.
So when it runs on a VM like this, and are you doing their network translation at the OS level, or how's it? So say I have two apps running on that same VM, and a host name A is supposed to go to AWS. Is that going to affect all the apps running on that VM, or?
So what you would have to do is you'd have to configure the proxy itself to refer to the correct port and the correct application, right? So from the proxy standpoint, what you're actually seeing is it's going to identify the service and the specific port it's running on. So you would have two proxies, each of which one would go to one port if you're doing multi-port, right? And then the other one would go to the other port. The health checks themselves you would also configure to the specific port. And in terms of upstream, for example, if you've got API and web both on the same machine, what you would have to do is you'd have to say the upstream would go to the proxy itself, right? So if it's the proxy, this could be any arbitrary port as long as it's not a port in use. So that's the key. If your app is on port 9090 and app 2 is on 9091, use a separate port for it to resolve upstream, right? So it says, okay, I resolved to app 2 using localhost 9092. And that would actually help with the, sort of the confusion. But it is a little confusing because each one would have to have their own proxy.
Okay, cool. Yeah. Thank you.
A bit of a basic question. My understanding is that AppMesh is sort of an alternative to Consul. So if you were building this AWS out from scratch, what would be the sort of trade-off to decide whether to do AppMesh or just to do Consul the whole deal?
Yeah, great question. So Consul you would have to deploy. You would have to sit and you have to put in the system, all of the system configuration and stuff. So, and that's a separate configuration. If you're already all in on AWS and you're saying, I'm just going to use whatever is available there, AppMesh is all kind of integrated. You have, I think, 1 or 2 lines that you add to your application configuration, and then it auto-registers it, and it deploys the Envoy proxy for you, right? So under the hood, both of them are using Envoy proxy. So that in that regard, they're pretty much the same. So if you wanted to do like vanilla Envoy configuration, you would be able to do it with both. But if you're saying, I don't really want to manage the control plane, you would say, I'll just use AWS AppMesh. But if you have a data center that you don't really have an option but to manage your own control plane on this, then you would just say, let's just stick with Consul for a little bit. Yeah.
Thanks.
No problem.
Hey, so if you're an organization or with like hundreds of AWS accounts and only just a few Consul data centers in like maybe just regions and like prod and non-prod kind of setup, what would be the best practice to basically keep everything? And the environment would be a mix of AWS AppMesh and also some part of like maybe EC2 instances, they all register with Consul. What would be the best practice to keep everything in sync?
So definitely the Cloud Map console. That synchronization is really useful because then it gives you an idea of the service catalog, right? So if you need to go back to a system of record, it could act as a system of record, right? And then what AppMesh will do is AppMesh will register back into AWS Cloud Map. So at the end of the day, as long as Consul's service discovery and Cloud Map service discovery are generally synchronized, you can at least get some visibility across all of them. Now, whether or not, I tried this and I haven't gotten it to work yet, but whether or not you can pass a Consul through Consul proxy to AppMesh proxy, I haven't actually experienced whether or not that works. So you still have, in terms of a better practice, right, you'd still have to keep both of them separate, but also be very cognizant of which ones are running AppMesh and which ones are running Consul. The idea is that if a service is in AWS and it's reflected in service catalog as running in AWS, you stick with AppMesh, for example, unless it's in data center or it's in the process of migration. So definitely, unfortunately, there's not a great way around it. I'm hoping that we'll get something better because under the hood, let's hope that the meshes themselves get together. There are, I believe, other tools available that actually have higher level abstractions that allow you to see between meshes themselves. But I'm not sure if they have integrations with AppMesh yet. Cool.
Hi, thank you. Very good, nice explanation. I had a question. If, say, you have multiple instances of the same API, how would that then start working with service mesh? And would service mesh handling balancing between them, or do you need like a load balance or something like that?
Yeah, that's a great question. So you would see it. It would balance between them. I think out of the box, it's round robin. It's very blind in terms of its balancing. But what it will actually do is actually register under the service ID. So what you'll see in here, for example, is you'll see, let's say this one, you'll see multiple instances of API, for example. So you'll see IDs registered, but you'll see ID with a different node. So it will load balance between the three when you do the service discovery piece, and that's if you're referencing it with the proxy in the upstream. Now, if you've got like a web application, for example, it's probably better just to use the load balancer. You could use the proxy is great. So what I showed here about the A and B testing is really useful. But you still need the load balancer there if you have very specific instances and very expected very high traffic, right? So that wouldn't be bypassed as part of your configuration in your on-prem, for example. Yeah. Thank you. Hope that answered the question.
Hi. How would this work if you have an existing API gateway in place, like Apigee?
Yeah. So if you have an API gateway in place, what it's already kind of doing is identity management of who's talking to who in your APIs, right? And so the big question I get is like, do I do service mesh or API authorization as a service? And my answer is if you've already got an API gateway, you might be fine with just the API authorization as a service. The service mesh piece is really useful for, at least in my view, for applications that are in a data center that you can't bundle libraries very easily. So for example, if you want circuit breaking, to say like, hey, there's expected retry and then cut off, right? It's not that easy for some types of applications to have a circuit breaking library built into the application. And that's where the proxies are really useful, and that's where the service mesh is really useful. If you've got a lot of APIs that already have all this capability in place, or you just don't need it, then you can continue with the API gateway. The service mesh, at least in my view, is a little bit like a distributed way of getting across all these different applications that wouldn't otherwise be able to do API authorization as a service. But there was a time where I ran API authorization service and service mesh, and it got complicated. So yeah, for now, if you've got API authorization as a service or API gateway to handle it, then you can just keep it for now.
Okay.
Yeah.
Thank you.
Any other questions? Oh, okay.
So if you have like hundreds of upstream microservices, do you have to define like a connect definition for each upstream microservice?
Yes, you would have to declare a connect configuration for a number of them. You can automate it, but you would have to declare a connect configuration with upstreams and where it's going.
How do you automate it in general?
So there are a couple ways that you can automate it. For the most part, there is a Terraform provider to do it. So if you're using Terraform across the board, that's one piece. The other piece is that with, I believe with Consul template, there we go. Great. With Consul template, you could actually possibly render it out. When you start to create the application, right? If you're doing it in Kubernetes, it makes it a lot easier. But you can just say, hey, like before you create the pod, create this Consul template, populate it with the upstreams and the ports that you want. And in that way, you would do it in a more automated fashion. But for applications that are sitting on virtual machines, or you would have to find a way to do configuration management on those machines individually. Yeah.
What would you say the overhead is added by Consul, and how is it compared to other service mesh like Istio?
That is a great question. I actually have not seen the benchmarks for it. There is a benchmark, I believe, by layer 5. I think they're called layer 5. And so I think they would have more information. We're looking at potentially doing more performance-related assessments on it. So far, we haven't seen anything that has stood out, but then again, we have not done it at like million-plus scale. So we're hoping to run a benchmark against that. If you're curious to learn more, feel free, we'll chat and see if we can get you that information.
I was actually wondering, is there an easy or kind of already available way what to do in the case of sync breakdown or complete lockdown in case that DNS records and service discovery is kind of killed in one of the ways because you will end up out of the sync records? And how does the console and how does the app mesh handle this?
Yeah, so unfortunately the synchronization does not account for that. It's pretty much just going to synchronize between the two. And so I think there's probably additional work that needs to be done if, let's say, it's breaking down and then you need to bring it back up again, that it actually resynchronize. It does resynchronize to a certain degree. So if I take something out of CloudMap, then it will actually remove itself from Consul, but the reverse may or may not happen depending on how many services are in Consul going on and then getting registered back to CloudMap. So I think I know CloudMap to Consul will actually remove the entry from Consul. I could do it now, but we're gonna see what happens. It does actually remove it, but then Consul to AWS CloudMap, there's still some concerns with whenever it changes IP addresses and then it gets reflected back to CloudMap. So, yeah.
So this might be a very basic question. I never thought about using service mesh for legacy applications. How do you suggest that you actually redirect the service calls within the legacy application through the proxy, or is that the magic layer 4 stuff you were talking about?
Yeah, so you would have to direct it. You would still have to tell it to direct through the proxy. So one good example of this, you would have to redo the configuration, right, to go through localhost. You could reasonably specify a bind address that's not local. So you might be able to create a new network interface and then funnel it through there. But I don't know. I think most of it it's probably better just to go back to localhost. This is a lot easier, at least from what I see usually in .NET applications actually. Older .NET applications, if you've got like application settings, most of the time when you're doing dev work, you're always going to check against local anyway, so you just continue using that, and then it just uses the proxies. But it will depend. You can bind it to a different address, but for the most part, we usually continue to use it against localhost.
Right, but there's no logic or magic in the console.
Sadly, no. Sadly, no. But it's a feature. I'll ask and see if maybe there's a nice magical way to do it. But sadly, no. All right. Any other questions? Okay. Thank you very much.